Hello, hi, this is Mr. Gagnon. We're going to talk today a little bit about solving a problem where we have something that's shot up in the air, straight up, and we're going to solve for two things. We're going to solve for, number one, the time it takes for this to happen, and number two, the height that it goes. Okay, so let's take a peek at an example. So in solving using our six-step method, okay, to solving physics problems, I'm going to draw a picture first. So I think in class I had mentioned that I had a bow and arrow when I was a kid, and I shot it straight up in the air. So if I have an arrow, okay, like this, that goes straight up in the air, okay, it eventually, excuse my crudity, it eventually, at the top of its path, it stops. So the velocity at the top um, is 0. Okay, so that's something we know for every object that's tossed up. Now, because this object is tossed up straight, we don't have to worry about any angles over here yet. So the arrow turns around and it goes back down. Okay, so it goes back down and hits the ground. So um, we know a couple of things about this. Even on its upward trajectory, the acceleration of gravity always pulls on it. And that number is always this 9.8 meters per second squared number. Okay, even if it's going up, it's still accelerating at negative 9.8 meters per second squared, because this initial velocity has, once it gets here, shows that it slows down. Okay, it accelerates negatively. And then once it hits 0, it passes through the 0 point and then starts to accelerate, and the velocity the velocity changes in the negative direction. Okay, so let's give this thing an initial velocity. Okay, let's say it is moving along initially and released from the bow at let's make it really fast. Let's say we've got a really good strong compound bow that gives us an initial velocity of 200 meters per second. And we are going to put a plus sign there because it shows that it's going up. I could also write a little n there to show it's north. Okay, two questions. So we've got our picture, we've got our knowns, and now we're looking for our unknowns. My first unknown is the time that it takes to get to the top. Okay, and also I also want to know how high it's going to go. And for the purposes of our lectures, we're using x as displacement. Eventually, we're going to change it to y, but let's keep it as x. All right, so we're going to show how high it goes and how long it's in the air. So first thing I want to do is just take a peek and make sure that I have everything here. Okay, velocity final at the top, acceleration, and velocity initial. So there is a formula that we can use to calculate the time that it takes for it to go up to the top. And that formula, if I look at my formula sheet, and I still need to look at it. I mean, occasionally I can get them without looking at it, but I still have to use it as a reference. So have it handy. If I look at the time formula for the first one, VF minus VO, or V naught over A. Well, I've got initial velocity. I've got a final velocity at the top, and I've got A. So I found my formula. So the formula that I want to use, which is like I think the fourth step of solving the physics problems, is T is VF minus V naught, okay, initial velocity, over the acceleration. And in this case, it's the acceleration of gravity. Okay, so in just plugging in some numbers here, VF at the top is 0. The 200 will go there, and that's over gravity. Now the second squared is one of the seconds is canceled, and then the other one is sent to the top when you're looking at the time. So time is a positive number, and it will be 200 divided by the 9.8. Okay, and we end up with a time of 20.4 seconds to get to the very top. Now, because it's accelerating at the same rate, it's going to take the same time to come down that displacement. So it's going to come down in the same time. So I can actually get the time total of 40.8 seconds. And I may have overestimated with this number. That's a pretty steep number. That's more along the lines of like a bullet, but we'll still stick with that number. Okay, so we've got the time it takes to get to the top, and then we've got the total time in the air. We sometimes call that hang time. The video is getting a bit long, so let's finish up here. So I want to find out the displacement here. What I do have is a formula that says that the initial velocity times the time plus half a t squared. Okay, so that's the one I want to choose. You have these accessible to you. So let's solve for that. My initial velocity is 200 meters per second. The time I got was to the top is 20.4 seconds. I'm going to bring it over here. Plus half times the acceleration of gravity. And then I'm going to square that time. 20.4 squared. Okay, so I'm left with this. So in the beginning part of it, we got 200 multiplied by 20.4. So x is 4080. And that's the first part. And then plus, so half at squared, so 0.5 times negative 9.8. And then times 20.4 to the second power. It's subtracting 2,039 meters and meters. So 4080 subtract 2039, and I'm left with the x displacement of 2,041 meters. Okay, so that gives us how high it goes, and we get a positive number, and that leaves it there. Okay, so there we got the height, and you've also got the time, and we've got the time total. And one more important thing to note is that this velocity here at the bottom is equivalent to the velocity at which it took off. So the velocity at the bottom, assuming there's no air resistance, is negative 200 meters per second. Okay, at the bottom there. Okay, and we'll do a couple more in class. But thank you for watching, and have a great day.